Awesome.
So glad I don't have pockets.
Here we go. Whoa!
Okay, everybody, and welcome to today's lesson. Today we're going to be talking about our minimums and maximums. And what I'd like to do to illustrate this is that you just got off the ride at Hershey Park. This is Fahrenheit, if you're familiar with it. This is a 93-foot drop right here at the top, down to the very bottom of this first curve that we hit. Okay, so what I want to really talk about is that, all right, here you are on the ride. As you're here on the ride, what you're doing is actually going upwards. You're going in a positive direction. And then when you get to the very top, that point at which you start screaming right up here, this is what you're looking at before you start heading down the slope of the other side. So what I'd like to really focus on today is this point right here. Okay, this point is the point in which we change direction. Here we're going up, and on this side we are going down. So as you're screaming your head off on this side, you keep following this path the whole way down, and you enter into this bottom loop, which heads right back up. The moment in which you change direction down here is also going to be called a certain point, which we'll talk about in a little bit, but we're really looking at the change in direction. Here we are going down, and here we are going up, a negative direction and a positive direction. This point right here is what we're really focusing on. So today's lesson, we're going to be learning about minimums and maximums, okay, and which one coordinates with each of these points. So one of them is this point up here, the highest point, and one of this is the lowest point down here as well. So as we take a look at our notes, here we have a maximum and a minimum. That's what we're going to be talking about. This is 11-4, the last section of chapter 11, which, if you remember, we were talking about functions in the beginning. A maximum of a function, a maximum. We got to think of that ride, that Hershey Park ride that we faced. So here's our ride over here, again, the beginning and the middle right there. So as we were going up in this direction, and then we change directions to go down, we have a point that we need to address that's right up here at the top. Okay, so a max of a function is nothing but the greatest. Okay, so the greatest value of the range of a function. Okay, remember the range is the y output, which we're talking about up and down. So if we're looking here, the greatest value, or the highest point in which we hit, is this point right up here. So this y value is going to be our maximum of a function, or a max. Okay, the min is just the opposite. So as we start heading our way down this first curve, we hit this second loop, which we start heading back upwards. So as we look here, this point right down here, the bottommost point, or the least value of the range of a function. So the smallest y value that we're going to hit or cross over is this point down here, so this one is going to be our minimum. So we have a max and a minimum. So this is the minimum of a function, or the least value of a range of a function. Most likely we're going to be discussing quadratic formulas. If you remember back to one of our earlier units, we talked about what a quadratic means. A quadratic is nothing but x squared as the highest degree of any term. So we're looking at this 2. That 2 makes it a quadratic function. So if we look here down at our function, we're just going to create one of our own. I'm going to make a quadratic trinomial. So we have our x squared plus 2x plus 1. This is just a generic formula, just out of the blue, random one. If we're looking here, our x squared is the highest degree because this is x to the first and this is x to the 0 over here. So if we're looking at this 2, that makes it a quadratic function. All right, a quadratic trinomial. The x squared makes it a quadratic, that's why. Okay. If we're looking at the graph of a quadratic, you've all seen it before, I'm sure you know what the term is, but if you do not, it's called a parabola. Okay. Down here is parabola as well, if you need to see it a little bit clearer. Okay, a parabola, you've seen it. We've been using them before. They look like the upside down U or the regular U. Now, the interesting thing about a parabola is if you're looking at a true parabola, it looks like it's going to finally level out and create a straight vertical line on either side. But in fact, it does not. It gets very close to doing that, but it does in fact go on forever towards infinity, positive infinity and negative infinity to the right and the left. So therefore, it is a function. It does not cross over. There are no more outputs than there are inputs. So that's what we're looking at. A parabola is nothing but an upside down U-shaped figure, or in right side up. So parabolas also have, we're looking at maximums and minimums. So what do you think a parabola has? It has a max or it has a minimum. Now question, can a parabola have both a maximum point and a minimum point? Okay, the answer is no. Because if you look at every parabola, there's only one change in direction, which is right up here at this top point. So this would be our max. Okay, or it has a change right there at the bottom, which is our minimum point. Okay, so there is only one point in which we're going to have a maximum or a minimum. These lines up here, like I said before, they do extend upwards towards positive infinity on this graph and towards negative infinity on this graph. But again, infinity is just a concept. There is no number that marks infinity. So just remember that it does head in both directions forever. Therefore, we can never truly reach a minimum or a maximum in those two directions. But there will always be one or the other. Now for some examples. If you're looking here, again, this is our parabola shape, our U-shaped figure. Again, it does extend it off to the positive direction towards positive infinity, so it does go on forever. It doesn't have a highest value, but if you look down here, we're changing direction down here at this bottommost point, this lowest point. So what is the least point that we reach? Is it a maximum or is it a minimum? Remember, if we change from a negative slope to a positive slope, we're looking at a minimum. So we will be focusing on just a minimum in this case. And our minimum can just be represented, remember, it's our range of each graph. So the range deals with the y-axis, so we're going to be looking at where it crosses the y-axis here. And fortunately for us, it crosses at 0, -2. So our minimum is nothing but y equals -2. All right? And like I said before, can you have a maximum and a minimum at the same time? Not with a quadratic function. So therefore, this you can just represent as none. There is no maximum. There is no maximum in this graph. So therefore, just y is equal to -2 is our minimum. And what I will be asking for is for you to put it in a ordered pair, okay, a point. So if we're looking down here, again, y is second. Okay, x's come first. If you look up here, our x crosses our -2 at 1. So we're just, at 0. So we're just looking at 0. 0, -2. Okay, moving on, if we look at this second problem, again, it's just this problem flipped over, upside down. So we're looking at a negative slope of our parabola. So if you're looking here, it starts going up, and then it changes direction and goes down. A positive direction to a negative direction. This point right here is going to be a maximum. So a maximum in this case is going to be y equals, where does it cross? Crosses right here at 4. So our y value of 4 is our maximum value that it can have. Again, we cannot have a min and max at the same time, so this is just none. Okay. Moving on, after we do this point here in a second, if we do a point of max or minimum value, again, we had a maximum value. So this is 4, and at the value of y equals 4, our x, or our input, is 0. Okay, easy enough. If we move on to this last example here, slightly different. It's just shifted off to the right and down towards the bottom. So if we're looking here, we are changing direction here at the bottom. So we are decreasing and then increasing. So this point right here is going to be a minimum. Y equals, we look here, our y crosses right here at our x of 2, -2. So this value here is 2, -2. That's our point, So if we're looking at our point of 2, -2, our y value is -2 as well. All right, our maximum, again, there is none. Okay? Okay, so in conclusion, just to sort of recap what we've just learned about our minimums and maximums, okay, a parabola. A parabola can have a minimum or a maximum. can have a minimum or a max. Okay? It must be or. It cannot be both. They have to be one or the other. If it's not the min, then you just put none for minimum value. They occur when directions change. So direction change. And what that looks like, once again, is if you have a parabola here, all right, we are going upwards and then we are going downwards. This is the point in which there is no up or down movement. We are changing our direction that we are going. So it happens at a direction change. So a parabola is a min or max. Direction change is where it happens. And lastly, just remember that min is least and max is greatest. Thanks for watching. This was Mr. Korb. Hopefully this helped you with your minimums and maximums of parabolas.